Good morning, all of you. Today we are going to start our discussion with partial differentiation. And first of all, I welcome you all for Engineering Mathematics 1 and your BE course. So, in this unit, we are going to discuss how to find the partial derivative of the given function. See, in your PU course, you have studied this concept, differentiation. Given a function y equal to f of x, how to find its derivative in the sense that represents how the quantity f of x is going to change with respect to the change in x, how the dependent variable is going to change with respect to the independent variable. So this you have studied for only one independent variable. See here, x is the independent variable. There is exactly one independent variable. Then if you have one independent variable, then finding its derivative is easy. You have to vary this x, then corresponding to that how y is going to vary, that you have to note down. That will be the derivative of y with respect to x, which can be written as dy by dx, or some will write this as f dash of x. And for this dy by dx we use different notations. So some writes y1, some other writes y dash. These are all the notations for the derivative of y with respect to its independent variable. See, in these two, dependent and independent variables are explicitly mentioned. Here x is the independent variable and f or y may be taken as dependent variable. But in these two notations, independent variable is not explicitly mentioned. So keep that in mind. So all these notations are equivalent. Now suppose if you have only one variable, then there is no problem, and you have studied that and you are familiar with that. Now the question is, suppose you have two independent variables, then how can I find the derivative of the independent variable, derivative of the dependent variable with respect to the independent variable? Suppose I'll consider this situation. This I'll call as ordinary derivative, or you can write ordinary differentials, ordinary derivative. This is ordinary, there is nothing more special in that. So the next case is, suppose we have two independent variables. Suppose y equal to f of x1 comma x2. Let us take a general case. When you have two independent variables, we will take that as z equal to f of x comma y. So usually we write this as the standard form. So we have z equal to f of x comma y. So here z is a function in two independent variables. I will take an example to understand this. Suppose you want a glass of hot water. Hot water will be an output, or you can take that as the dependent variable, and the independent variable is cold water. I'll write here. So we'll take cold water, then boil it, we get hot water. So this you can treat as x and this you can treat as y. So here y is depending only on x. There is only one independent variable. If you take 1 liter here, you may get some other quantity here. If you get 2 liter, then definitely this quantity will change. So with respect to change in x, you get change in y. How that is going to change, that will be the derivative. So dy by dx represents how y will be changed with respect to the change in x. Okay. Suppose you want to prepare coffee. Then it has three ingredients: cold water, then sugar, then coffee powder. It may be a small change or large change, whatever it may be, but varying these quantities definitely varies the quantity of the output coffee. If you change, if you minimize or maximize, if you change the quantity of cold water, definitely there will be change in coffee. Even if you add more sugar, the effect of this is very less. Time being, you can rule out this one. So you can consider only two variables, cold water and coffee powder. Now, this situation you can compare with this partial differentiation. Here there is an output or there is a dependent variable which is going to depend on two independent variables, cold water and coffee powder. So that is what the case I have written here. So Z is a dependent variable and it is dependent on both X and Y. Now, how to find the change in the quantity with respect to one ingredient? What I have to do to find the change in coffee with respect to cold water? I have to add same quantity of sugar and coffee powder. Then I have to change only this. Water matra change ಮಾಡ್ತಾ ಹೋಗೋದು. So when you change only the cold water quantity, keeping sugar and coffee powder quantity same, you get to know how the quantity of output is going to vary with respect to the input. That's what we are going to do here. See, I'll repeat the case once again. I want to change how this output is going to vary with respect to this input, how the quantity of coffee is going to change with respect to the change in quantity of cold water. For that, I have to keep these two constants. If I change any one of these quantity along with the quantity of cold water, then change in this parameter also affect this one. So you can't get the correct answer. That will be not accurate. So to find the change in the dependent variable, when it has more than one independent variable, I have to change only one independent variable and keep all other independent variables constant. So to find the derivative of z with respect to x, what I have to do? I have to differentiate with respect to x. That's what I am doing here. I have to change the quantity of cold water, keeping the sugar and coffee powder quantity same. I have to change with respect to, I have to differentiate z with respect to x, keeping y as constant. So the notation for that is dou z by dou x. This is called dou. So dou z by dou x represents partial derivative of z with respect to x. See, we are differentiating partially in the sense, ಇಲ್ಲಿ ಒಂದು ಇಂಡಿಪೆಂಡೆಂಟ್ ವೇರಿಯಬಲ್ ಇತ್ತು, ಒಂದರಿಂದನೇ ಡಿಫ್ರೆನ್ಷಿಯೇಟ್ ಮಾಡಿಬಿಟ್ವಿ. ಇಲ್ಲಿ ಎರಡಿದೆ, we have two independent variables here, and we are not differentiating with respect to both variables. We are differentiating with respect to only one variable. That means the process of differentiation is applied partially. The process of differentiation is applied partially here. So it is called partial derivative. The symbol for partial derivative is dou. Whenever you have only one independent variable, we use this d. Whenever you have two independent variables, we use dou. If you have three independent variables, then what is the notation? Then also same, you have to use dou. So only one independent variable, you have to use d. More than two independent variables, two or more than two independent variables, you have to use dou. So dou z by dou x. So for this, mathematically I can write expression as limit as delta x tends to 0, f of x plus delta x comma y minus f of x comma y divided by delta x. This you can use write using first principle to find the derivative. Okay, this is done. I have differentiated partially with respect to x. Similarly, we can differentiate partially with respect to y also. To make the notation simpler, we can write this as zx. Zx that represents partial differentiation of z with respect to x. ಮುಂಚೆ ಹೇಗೆ ಆರ್ಡಿನರಿ ಡೆರಿವೇಟಿವ್ಗೆ ನಾವು 4-5 ಥರ ನೊಟೇಷನ್ಸ್ ಇಟ್ಕೊಂಡಿದ್ವಿ, ಅದೇ ರೀತಿ ಪಾರ್ಷಿಯಲ್ ಡಿಫ್ರೆನ್ಷಿಯೇಷನ್ಗೆ 2 ನೊಟೇಷನ್ಸ್ ಬರುತ್ತೆ. ಝೆಡ್ ಎಕ್ಸ್ ಅಂತ ಬರೀಬೋದು, ಇದು ಡಿಪೆಂಡೆಂಟ್ ವೇರಿಯಬಲ್, ಸಬ್ಸ್ಕ್ರಿಪ್ಟಲ್ಲಿ ಬರೋದು ಇಂಡಿಪೆಂಡೆಂಟ್ ವೇರಿಯಬಲ್. ಅದೇ ರೀತಿ ಡೋ ಝೆಡ್ ಬೈ ಡೋ ಎಕ್ಸ್ ಅಂತ ಬರೀಬೋದು. ನೆಕ್ಸ್ಟ್ ಝೆಡ್ ವೈ, ದಟ್ ಈಸ್ ಆ್ಯಕ್ಚುಲಿ ಡೋ ಝೆಡ್ ಬೈ ಡೋ ವೈ. ದಟ್ ಈಸ್ ಲಿಮಿಟ್ ಆಸ್ y tends delta y tends to 0 f of x comma y plus delta y minus f of x comma y divided by delta y. So this is for the partial derivative of z with respect to y. So given a function z equal to f of x comma y, we got 2 types of derivatives. Similarly, if you have 3 independent variables, then you get 3 types of partial derivatives: zx, zy. Next, suppose we differentiate this again, second order partial derivatives. You have studied in the case of ordinary derivatives, first order derivative, second order derivative, third order derivative, and it can go up to nth order derivative. Now from the view of partial differentiation, I have first order derivatives. Now can we find second order derivatives? Yes, we can find second order derivatives also. Differentiate this zx with respect to x partially again. So this, if you differentiate with respect to x partially again, then it will be dou z by dou x of dou z by dou x of dou by dou x of dou z by dou x. That means you have to consider this dou z by dou x, then again differentiate that with respect to x, keeping y as constant. So keep that in mind. There is no much difference between our partial derivatives and ordinary derivatives. Only thing is, in the case of ordinary derivatives, you will be having only one independent variable, so you will differentiate directly. In the case of partial derivative, you will be having more than one independent variables. You have to differentiate with respect to one independent variable at a time and keep all other independent variables as constant. So keeping all other independent variables ಅನ್ನೋ ಲೈನ್ ಅನ್ನು ತೆಗೆದಾಕಿದ್ರೆ partial differentiation ordinary differentiation ಎರಡು ಒಂದೇ. So only that is the difference, keeping all other variables constant. Apart from that, there is no much difference between ordinary differentiation and partial differentiation. ತಲೆ ಕೆಡಿಸ್ಕೊಂಡು ಕೂತ್ಕೊಳ್ಳೋಂಥದ್ದು ಏನಿಲ್ಲ ಅಲ್ಲಿ. ಪಾರ್ಷಿಯಲ್ ಡಿಫ್ರೆನ್ಷಿಯೇಷನ್ ಅಂದರೆ ಏನು ಅಂತ ತಲೆ ಕೆಡಿಸ್ಕೊಂಡ್ರೆ ಇಟ್ ವಿಲ್ ಬಿ ಸ್ಟಿಲ್ ಕನ್ಫ್ಯೂಸಿಂಗ್. ಯು ಹ್ಯಾವ್ ಟು ನೋ ವೆಲ್ ವಾಟ್ ಈಸ್ ಆರ್ಡಿನರಿ ಡಿಫ್ರೆನ್ಷಿಯೇಷನ್, ದೆನ್ ಯು ಕ್ಯಾನ್ ಅಪ್ಲೈ ದ ಸೇಮ್ ಥಿಂಗ್ ಹಿಯರ್ ಫಾರ್ ಪಾರ್ಷಿಯಲ್ ಡಿಫ್ರೆನ್ಷಿಯೇಷನ್. ಓನ್ಲಿ ಥಿಂಗ್ ಈಸ್ ಕೀಪ್ ಅದರ್ ವೇರಿಯಬಲ್ಸ್ ಕಾನ್ಸ್ಟೆಂಟ್. Now if you consider dou z by dou x, differentiate that with respect to x partially again, you get dou square z by dou x square. That I can write as z double x. Z double x. Now similarly, if you consider dou z by dou y and differentiate that with respect to y partially, then you get dou square z by dou y square. That will be actually z double y. That will be actually z double y. Now the thing is, I have dou z by dou x. I have dou z by dou x, and I have differentiated that with respect to x partially to get this dou z double x. What happens if I differentiate this dou z by dou x with respect to y? That is also possible. You have this dou z by dou x. Again, it may be function of both x and y. If you differentiate that with respect to x, you get dou square z by dou x square. Very good. Suppose I differentiate dou z by dou x with respect to y. I'll write that here. Dou z by dou x, dou by dou x of dou z by, okay, this I had to write y, right? Yes, y, dou z by dou x. This you can write as dou square z by dou y dou x. Okay, I got mixed derivative because this involves both the independent variables. So this is called mixed derivative z y x. Similarly, if you consider z y and differentiate that with respect to x, you get z x y. Is there any relationship between these two? ಇಲ್ಲಿ yx ಇದೆ, ಇಲ್ಲಿ xy ಇದೆ. And these are called mixed derivatives. As I said already. Mixed derivative ಅಂತ ಯಾಕೆ ಹೇಳ್ತೀರಾ? x ಇರುತ್ತೆ, y ಇರುತ್ತೆ, ಎರಡೂ ಇಂಡಿಪೆಂಡೆಂಟ್ ವೇರಿಯಬಲ್ಸ್ ಅಲ್ಲಿ ಇರೋದ್ರಿಂದ ಅದನ್ನು ಮಿಕ್ಸ್ಡ್ ಅಂತ ಹೇಳ್ತೀವಿ. Now, what is the relationship between, first question, is there any relationship between these two derivatives? Yes, there is a relationship between these two. When the function is continuous, whenever the function z equal to f of x comma y is continuous, in that case these two will be equal. If z continuous, if z is a continuous function, then zxy will be same as zyx. Otherwise, they may be equal or may not be. So, for your course, usually we will consider only continuous functions. So, generally we say that zyx will be equal to zxy. That is general statement. ನಿಮಗೆ ನಾವು ಯೂಶುವಲಿ ತಗೊಂಡಿರೋಂಥ ಪ್ರಾಬ್ಲಮ್ಸಲ್ಲಿ ಮ್ಯಾಕ್ಸಿಮಮ್ ಎಲ್ಲ ಈಕ್ವಾಲಿಟಿ ಇರುತ್ತೆ. And these two are called, as I said, mixed derivatives. Derivatives. And these derivatives are called second order partial derivatives. Second order partial derivatives. And these two are called first order partial derivatives. Can we continue this process? Sure. You can differentiate z double x with respect to x again. So this you get z double x. Oh, sorry. If you differentiate with respect to x again, z triple x, z double x y. If you differentiate this with respect to y partially, in any other case, okay, from this z double x you get 2. From this, these two are equal, so don't worry about it. Zyx, zyxy, okay, zyxy, zy double x. Similarly, you get zx double y and zxyx. zxyx, zx double y. So this will be equal, obviously. Iveradu equal antandre, so definitely you equal agirlebeku. And from this z triple y, z double yx. And these are called These are called third order partial derivatives. These are called third order partial derivatives. Partial derivatives. Yes. So initially you had only one function, then two, then four, then 1, 2, 3, 4, 5, 6, 7, 8. Next you will get 16, then 32, 64, and so on. That will continue. So similarly, you can define or you can find higher order partial derivatives. So this is about the introduction to partial differentiation process. Only thing is, you are applying ordinary derivative or ordinary differentiation, keeping only one parameter as variable and all other parameters as constants. That is the only difference. Nothing else is discussed here. So then we got idea about higher order partial derivatives and mixed derivatives, and these are also you can call as mixed derivatives. Don't say mixed derivatives. There is only mixed derivatives. So this is about the definition and introduction. So next, I hope I can start with the syllabus. Problems. This comes under syllabus only. Don't confuse. Let us take some simple problems to understand how the partial differentiation can be done. Find the partial derivative of the function. Okay, it takes a bit higher level question only. If u equal to problem 1, if u equal to x cube minus 3xy square plus x plus e power x cos y plus 1, show that dou square u by dou x square plus dou square u by dou y square equal to 0. Solution. So u is given, that is function in two independent variables x and y, and you have to show that dou square u by dou x square plus dou square u by dou y square is equal to 0. What do we have to do? First, write down the given thing. Given u equal to x cube minus 3xy square plus x plus e power x cos y plus 1. That is the given function, and you have to show that dou square u by dou x square plus dou square u by dou y square equal to 0. Forget about that equal to 0. First, try to determine this dou square u by dou x square. How can we find dou square u by dou x square? That represents the partial derivative of u with respect to x twice. Dou square u by dou x square represents partial derivative of u with respect to x twice. Alva? So you have to differentiate u with respect to x 2 times partially. Then dou u by dou x equal to. So I have to differentiate this expression with respect to x, treating y as constant in your mind. Fix y is a constant. Fix ಮಾಡ್ಕೊಳ್ಳಿ y ನ constant ಅಂತ ಮೈಂಡಲ್ಲಿ differentiate ಮಾಡಿ ಈಗ with respect to x. So differentiation of 3x square will be x cube will be 3x square minus y square constant, that will be retained. Derivative of minus 3x, you get minus 3. Derivative of x 1. Derivative of e power x cos y. Cos y is a constant term, so there is no change in that. Derivative of e power x is e power x. Differentiate it again. Dou square u by dou x square. 3x square, differentiating, you get 6x. 3y square, that is purely a constant term. It involves it is not involving x term, so the derivative of minus 3y square will be 0, plus 1, if you differentiate that you get 0, plus e power x cos y, that will be again e power x cos y. So I got dou square u by dou x square. So time being, call that as equation 1. Next, again you have to start with the given thing, because I have to differentiate with respect to y. So start with the given thing. Dou u by dou y equal to differentiating u with respect to y, where x is treated as constant. So x cube, differentiating you get 0, minus 3x remains a constant term, into derivative of y square. Derivative of y square is 2y. So 2 into minus 3, minus 6. X constant, that is carried as only. So minus 6xy. Plus derivative of x, because we are treating x as constant, derivative of x will be 0. Derivative of e power x cos y, e power x ಹಾಗೆ ಇರುತ್ತೆ, cos y ಡಿಫ್ರೆನ್ಷಿಯೇಟ್ ಮಾಡಬೇಕು, ಮೈನಸ್ sin y ಬರುತ್ತೆ. ಸೊ e power x minus e power x sin y. Dou square u by dou y square, again you have to differentiate with respect to y, minus 6x minus e power x cos y. Now add equation 1 and 2. ನನಗೆ dou square u by dou x square plus dou square u by dou y square ಬೇಕಲ್ವಾ, ಸೊ ಆ್ಯಡ್ ಮಾಡ್ತೀನಿ. ಇಲ್ಲಿ dou square u by dou x square ಇದೆ, dou square u by dou y square ಇದೆ, ಅವೆರಡನ್ನೂ ಆ್ಯಡ್ ಮಾಡ್ತೀನಿ. ಏನು ಬರುತ್ತೆ, ಆ್ಯಡಿಂಗ್ equation 1 and 2, adding equation 1 and 2, we get dou square u by dou x square plus dou square u by dou y square equal to, now write down the right hand term of equation 1, idalva 6x plus e power x cos y. Right hand term of second equation, minus 6x minus e power x cos y. So 6x get cancelled, e power x cos y, e power x cos y get cancelled, remaining 0. Therefore dou square u by dou x square plus dou square u by dou y square equal to 0. Similarly, let us take one more question. Okay, problem A ಅಂತ ತಗೊಂಡಿದ್ನಲ್ಲೇ, problem 1 ಅಂತ ತಗೊಂಡಿದ್ದೆ. Okay, problem 2. Problem 2, okay, I'll write from here. If u equal to log of x square plus y square divided by x plus y, show that x ux plus y uy equal to 1. Here you have to recall this one. Ux means that represents partial derivative of u with respect to the independent variable x. Uy, that represents partial derivative of u with respect to y. And derivative of log x, d by dx of log x is 1 by x. Actually that is 1 by modulus x. Here also you have to write. But generally we don't use mod x. Derivative of log x is 1 by x. Keep that in mind. Solution. First write down the given thing. Given u equal to log of x square plus y square divided by x plus y. differentiating with differentiating with respect to x partially. Would you get ux equal to, or you can write dou u by dou x notation, dou u by dou x equal to log of x square plus y square, whatever the term you have in bracket, see, log of x, differentiating that you get 1 by x. So whatever the term you have under bracket, you have to write that here 1 over that term. So x square plus y square divided by x plus y. Otherwise you can do one thing, yes, it will be a bit difficult, better you can do like that. You can rewrite this as log of x square plus y square minus log of x plus y. See, yes, this one will be easier. So I'll get ux equal to, differentiating this, log of x square plus y square, that will be 1 by x square plus y square, into derivative of x square plus y square, derivative of x square is 2x, plus derivative of y square 0, minus log of x plus y, differentiating that will get 1 by x plus y, into derivative of x you get 1. So from this, x ux equal to 2x square divided by x square plus y square minus x by x plus y. Call this as equation 1. Next, similarly, differentiating with respect to y partially, differentiating with respect to y partially, you get uy equal to, same thing you get 1 by x square plus y square. So first time you get the same. Next, derivative of x square plus y square, you are differentiating with respect to y partially, keeping x constant. So x square after differentiation it will be 0, you get 2y minus 1 by x plus y into 1. So y into uy will be 2y square divided by x square plus y square minus y by x plus y. Now adding equation 1 and 2, adding 1 and 2, you get x ux plus y uy equal to, see, x ux plus y uy equal to, now write the right hand terms, 2x square divided by x square plus y square minus x by x plus y plus 2y square divided by x square plus y square minus y by x plus y. See, if you have common denominators, then you can add numerators, alva. So using that, don't add denominators also. You can add these two because they have common denominators. So it will be 2x square plus 2y square divided by x square plus y square. Then these two minus you can take common, x plus y divided by x plus y. So these two get cancelled, you get only 1 here. Next, this will be 2 times of x square plus y square divided by x square plus y square minus 1. So again these two get cancelled, 2 minus 1, you get 1. Therefore x ux plus y uy equal to 1. That completes the solution. So next, let us write one problem for exercise. So try to solve this. If u equal to e power minus 2 pi square t sin pi x sin pi y. Prove that u double x plus u double y equal to ut. It's a function in 3 variables. Try to solve this one. Let us see the solution in the next video if you don't get the solution.